As soon as you walked in.
Peyton, are you being serious or are you being silly? I'll show you what. All right. So v of t equals x prime. So bless you. Your derivative here would be 6t squared minus 42t plus 72. And what does the words at rest mean to you?
When the derivative equals 0.
Hey guys, you should listen. Yeah. So Logan said when velocity is 0. I want to point something out though. This just says this particle is moving along the x-axis. So in this case, he's right. But if this particle was moving left and right and up and down, for it to be at rest, what else would have to be true? Both velocity components would have to be 0, right? So here it's just moving left and right. So this is enough, isn't it? Yeah. Okay, so equals 0. So Peyton, I got to say, anybody else that was, stumbling on the factoring here, wouldn't it make a lot of sense to divide everything through by 6?
Yeah.
That helps a lot, doesn't it? So if you divide everything through by 6, you get t squared minus 7t plus 12 equals 0. Peyton, does that make it easier?
Yeah.
Okay. So if we ever run into one of those other factorings where the a value is not 1, I'll show you a way to do that. Okay, so then you just get t equals 3 and t equals 4. Those would be the times when the particle is at rest. What do y'all think?
Yeah,
Good? Okay. So let's talk about vectors. We're going to talk about some vector basics and some symbology. We'll get into maybe 1 or 2 examples today. Whoops. So you got to fast forward a little bit to vector basics. Okay.
You don't like the exam part again?
Yeah, I feel like it was supposed to be a surprise, and I didn't mean to tell everybody.
Okay. So we've talked about this before, but no longer will the particles we deal with just do this or this. They'll go left and right and up and down all at the same time. They'll never go at you or away from you. That would be if you did a Calc 3 class, but ours will no longer just do this or just this. They go left and right and up and down all at the same time. So it's 2D vectors instead of just 1D. We've done a lot of 1D vectors. This is 2D. Make sense? So then if you've had a physics class, a lot of this is hopefully going to make a lot of sense. Velocity is a vector, and so vectors can be divided up into components, and we will very, very frequently do that. We'll divide up into those vector components. You good?
Yeah.
Sit back and relax.
Hi,
I was going to say so.
I was doing it. I'm good.
There we go. Okay.
Yeah.
Okay, so then would you guys agree with me that this particular vector, this velocity vector I've drawn, isn't it going up and right?
Yes.
So then the horizontal component, we would call this Vx. The vertical component, we would call V sub y. So the V sub x and the V sub y are just saying that this is the horizontal component, and then the V sub y would be the vertical component. And those can be broken down into what those actually are. And you'll see this down below in the little box. Vx is equal to the velocity vector times cosine of theta, cosine of the angle being right there. And then Vy would equal V times sine of theta, again with theta being in the same spot. So you've had a physics class. Hopefully you're thinking, yeah, I've heard this a million times, right? If you haven't, this could be new. This won't be a major factor in how we do things here. It's not really a physics class, but there's just enough of it where it's probably worth talking about. Let's remember that if we are going to go from a velocity to a position, we integrate. And so if you look at down here in the box, it says the position vector would be Vt cosine theta or Vt sine theta, depending on which one we're talking about. Gravity would need to be considered, initial position would need to be considered, and you'll get all those initial conditions within the body of a question. One little note here you'll see, and sometimes people are really uncomfortable with this. What is gravity's acceleration in feet per second.
16.
Not 33, not 16,
27.
not 27.
24.
9.81.
That's in meters per second.
That's embarrassing.
So that's in meters per second. What about feet per
I thought I
second?
messed up. It's
The 33 was really close.
31.
29.
34.
32.
32, but it's not 32. It's really,
First try.
it's negative 32.
See, I got half of that exactly. Stupid impurity.
So that's just what shows up sometimes. So I just thought
That's like
I'll share.
Thank you, but I
You're welcome. So let's see here. I want to point out some of the things we can find, and we'll be doing this here in a minute. Let's say that I've got,
As a child, I felt.
let's say I've got like a coordinate axis system here
I was wearing. Whoosh. Sliced them up.
with an x-axis and a y-axis. And let's say that as time goes, let's say that the particle or the object, whatever it is moving around like this, and it does one of these and goes over there and stops right there. We can do a lot of things with this. So number one, we could find total distance traveled, right? Number two, we could find the tangential path of the object at any point. So in other words, if the object was freed from the constraints that are making it go in this, like if it just took off in a straight line. So for instance, let's say this particle was moving along here, and whatever was making it do what it's doing, maybe it was a string or something, or somebody holding onto this object, whatever it was, say that that string broke like right there. Wouldn't you agree that the particle would shoot off at about that angle? So if it's going to shoot off at that tangential angle, what are we talking about?
derivative.
Because the derivative would give you what?
Slope of the tangent.
Slope of the tangent line, which is that tangential direction, right? We could find the equation of the tangent line and predict where that object would go if it broke free from its constraints that were making it go in that pattern, right? We can find the angle that it's at from the origin or from where it is at that particular time, at any time we want. We can find the total distance traveled. I feel like I'm forgetting. Oh, we can find the speed at any point along the... And speed, because, think about this. If I just said define speed, what would you say?
How fast
How
something
fast an
moves.
object is moving without worrying about which direction.
Without regard to direction, or you could say the absolute value of velocity. So let's go there. If I told you that, think about it like this. What if I said velocity equals -7, and I said, what is speed? What would you say?
7.
Absolute value of -7 is 7. However, and that's in 1D, right? That's just when it's moving left or right or up and down. What if I told you that the velocity vector was -3, 10? And by the way, what does that mean if the velocity vector is -3, 10?
That's I hat, J hat, so that's a vector.
So which way is the object moving if the velocity vector
Left
is
and up.
left and up?
Okay, I don't know.
We'll get into the symbology here in a second, but that is I hat and J hat.
That's
You can't just do this.
-3 squared.
You can't just say, I'll just do the absolute value and you figure out the details. There's going to be a little more to it than that, right? And it's going to involve some Pythagorean theorem-y kind of stuff, right? Got to find the resultant. Okay. So let's go ahead and look at the symbology here. So flip over to the next page. So
No,
if we are looking for the tangential path of this, some object moving around, then we are talking about the slope of the tangent line, like you all just said. And I'm hoping that what you see in the blue box looks really familiar to you.
That's what we just did.
That's what we just did. That's right. So the slope of the tangent line for vectors, 2D vectors, is the same as the slope of the tangent line for 2D vectors, right? By the way, when you get in three-dimensional calculus, like free space, you don't get tangent lines anymore. You get tangent planes.
Oh, I don't
No.
like that.
You got to learn how to write the equation of a plane,
No.
and you do. It's actually really cool.
One thing I'm not going to be doing that ever.
All right. That makes me sad because I think you could probably be pretty good at it.
This is the last math class I ever have to take.
Okay. Well, let's get really good at it,
Yeah.
so that indeed does end up being true. Very well could be true.
If you want to do architecture, there's no way that's
Yeah, no, I tested out everything.
I've talked with plenty of folks where that's been the case. Okay, you guys, oh yes, Meg?
I have a question a little off topic. Is that okay?
I may or may not answer it.
So I can ask it.
Make it quick.
Okay. In college, if you're doing pre-med, do you have to take more math classes?
Well, it really depends on the program. So I think you probably could find programs where there's more or less math. But I would be, probably depending on the program, I would be willing to bet that if you pulled a 5 out on the BC, I bet you there would be a lot of programs where they would say exactly what Logan's talking about, where they're like, hey, you proved you know a lot of math. You're done. That very well could be the case. You'd have to check the program out, though, just to see what they require. There could be others that they feel like you need more math, and you might have to take like one more class or something. But I will say this, like, people make the mistake of thinking, you know, calculus A, B, or BC is just for the kids that are going to be engineers or statisticians or math majors or whatever. And if you are, that's great. Other people, really the real value here is what you're talking about. What you're talking about. If I'm going to major in English literature or medicine or architecture, and I found out that if I get a 5 on the BC exam, then I can go on and focus on architecture and I don't have to worry about doing any math anymore. Isn't that a major service to you? Like, that's a win for everybody, right? You're like, all right, I'm going to just focus on my English literature now, and I don't have to worry about derivatives or algebra or anything anymore. That's great. That makes sense? Or if, of course, you understand if you're going to be a math major then or an engineer or something, you understand the value there as well. So anyway.
What are you majoring in?
Architecture.
Okay.
That's sick.
Art Vandelay.
So an architect, and then
Yeah,
Nobody knows what I'm talking
sick
about.
that I'm doing.
it is
Art
sick.
Vandelay?
Don't.
Nobody, has anybody ever heard of Seinfeld?
Oh,
I heard of
what
it.
was your major?
What?
What was your major?
Math.
I'm gonna go with
Math and education. Yeah, it's true. It's true. Hey, do you guys recognize the red box?
Yes.
Yeah. I did
So if
that
you're
in
going to
session
consider
two.
concavity, or as the slope increasing at a decreasing rate or increasing rate, you'd find the second derivative with respect to x. Hopefully that looks a lot like that parametric second derivative you all found. Yes? Okay. So those are all the
So
same.
that's the acceleration one.
Oh, no, you got to be so careful here. No. So, okay.
I'm sorry.
You did something.
Wait,
You must
how
feel
is
so
that?
badly about
So hang on. So we'll get into these symbols here in a second.
Wait, is that the direction?
So position. I'm jumping the gun a little bit. You'll see that I'm kind of repeating myself, but I want to address this right now. A position vector would be something like x of t, comma, y of t. That would tell you the actual location at a particular time. The velocity vector, of course, would be x prime of t, comma, y prime of t. That would tell you that it's going down and right, or whatever. The acceleration vector would be x double prime of t, comma, y double prime of t. And that would tell you is the velocity increasing or decreasing or, whatever, right? When we talk about these over here, this is specifically talking about, the blue box is talking about the slope of the path that this object is making. So it's the slope of the tangent line for that path. And of course, the red box is the slope of the slope of the path. So it's really tempting to say, oh, the second derivative, just some generic second derivative, that's acceleration. Not really, right? So the d squared y over dx squared would tell you about the concavity of the path of the object as it moves around.
Mr. Rob.
X double prime, comma, y double prime, that would tell you the acceleration vector. That would actually be how fast is this object accelerating. Does that make sense?
Yes.
Okay. So be really careful about like the generic second derivative. Try to be as specific as you can. So I already kind of showed you this. You might see these interchangeable. X prime equals dx dt. It's the same thing. It refers to the rate of change of the x-coordinate, aka the horizontal velocity component. And y prime equals dy dt. That would be the vertical velocity component. This is all just about symbology, so that later on we don't have to say, Sam, you remember the thing with the stuff and the pointy deal and the thing, right? You're going to give me that look, right? Instead, if I said, hey, Sam, think about the velocity vector. In fact, think about the horizontal component. You can say, I'm still confused, but at least I know what we're talking about. Instead of like the thing with the deedy bob and the pointy thing with the deal, right? Okay, so some other symbology stuff here. So this is basically what I just showed you. The physics folks in here, I don't know if you guys have done too much with this. I think some of you have.
Well,
Yeah, so, if you had, there's a couple different ways to do these. So if you had a position vector of 3, -7, you can write it with those pointy parentheses things like I've got up there. You can also write it as 3 I hat. Well, I guess I'd just write a minus there. -7 J hat. That indicates that you've got a vector as well. In fact, there's some technical stuff there where the I hat and the J hat need to be bold sometimes. I don't know if you've gotten into that. I had a physics professor that was like super mad if you didn't make things bold that needed to be bold. And it was kind of hard when you're just doing things with just a pencil and paper, whatever. You just had to like really scratch that I in there real good. It's like, okay, it's bold.
It took me an hour and a half of my attempts on the online homework to figure out how to just like write. I had
Oh, like in the
actual
computer?
thing. It
Yeah.
sucked.
I hate it when don't you hate it when the challenge of the homework is like, how do I type this in?
Exactly. I
hate
know
that.
exactly what the answer is. I can
Like,
tell you.
if you could
straight
just
up.
like show the computer your paper, you'd be good.
Like, I know
Sure.
exactly what we're doing, but apparently not.
And then of course, x prime, y prime would be the velocity vector, x double prime, y double prime, the acceleration vector. You will see this notation frequently. You will not see the I hat, J hat notation on like an AP test.
Yes.
So I'll try to mimic that. I'll just go with the pointy parentheses to indicate that it's a vector. Yes, we good?
Cumbersome.
Okay.
Like, forget it.
The speed, this is what Aiden was kind of getting at earlier. The speed, we can't just do the absolute value of something and just call it good. Technically, this is still what we're doing, but you've got to use the Pythagorean theorem. Let me show you what I'm talking about. If I've got a horizontal component and I've got a vertical component, y'all still with me? I feel like maybe you're disengaged a little bit.
I'm with you.
I'm engaged, but I ran out of hugs.
Okay. So if I were to show you this set of vector components, which direction would you say that the object is going?
Up and to the right. Up and right.
Up and right, yep. So that doesn't directly tell me the speed. Speed is also known as the magnitude of velocity. And so, let me try that again. If I were to draw that in, that hypotenuse, this would represent the velocity vector right there. Now, speed, as you all said earlier, that is how fast the object's going, and we don't really care the direction, right? So I'm only looking for how long that purple line segment is. And so to do that, I would just do the Pythagorean theorem. So here's a quick proof. You would say v squared equals dx dt squared plus dy dt squared. And then how would I get the v by itself? Square root. And why would I not consider the plus or minus versions of that square root?
Because speed is absolute value and absolute value is positive.
Correct. So I would just take the positive version of that and go with that. There you go. Okay. So one of the more useful formulas for sure, but sometimes misused, is this one. And that is determining the angle, and this for us would be in radians.
Holy crap.
The angle of the particle at any time t equals a is equal to the inverse tangent of dy dx at that particular point in time. I'm going to draw you a picture to maybe help you understand a little bit about what this is talking about. So if I had, so here's the y-axis, here's the x-axis, and
Oh, that's all it is.
so let's say I had some object going from like here to here. It's not too hard to find the equation of the tangent line at a particular point in time. So let's say we wanted to know the equation of the tangent line like right there. Of course, the tangent line itself would look, let's try that again. Come on, computer. Something like that. That would be my tangent line. But there will definitely be reasons and times where we're going to want to find not just the slope, but the angle, which is what this is talking about. So let me draw in the components here real quick. This green, wouldn't that be the vertical velocity component? So I would call that dy dt. And then the orange one here, subject is moving down and right, so the orange one would be dx dt. Okay, so let's think this through. dy dx equals dy dt over dx dt. Does that make sense? Okay. Okay, so if I want to find the angle, I'll rewrite this. I'll just kind of come full circle here and try to prove this to you. Couldn't I say that tangent of theta equals dy dx? And then that would equal dy dt over dx dt? That make sense? Isn't dy dx just dy dt over dx dt? So then this will tell me what my theta is. If tangent of theta is dy dt over dx dt, wouldn't theta have to be right there? Okay, so here's the important thing to think about. This formula will tell you the angle from horizontal. Right? Because if I just said, hey, I'm heading up, if I just told you, hey, I'm going to go home and I'm going to go on a heading of 31 degrees, bless you, wouldn't you want to know 31 degrees from where? Because wouldn't 31 degrees from north be very different than 35 degrees from east? Or 31 degrees, whatever I said. And so we want to understand that this is the angle from horizontal, bless you. And so if you know what dy dx is, and you just do the inverse tangent of it, that'll tell you the angle from horizontal that this object is going. The final formula here, I think, is the total distance traveled. And I hope that once again, like before, this looks really familiar to you all. Where have you seen this before?
That's the length
That's the length of a parametric.
Yeah, length of a curve, right? Length, arc length is what we called it in parametric. So hopefully that makes sense when you think about all the different little paths that we've drawn. Like if an object is doing this, wouldn't it make sense that total distance traveled would be the same as the length of that curve in parametric? Hey, here's a big hint, or hopefully I'm not letting the cat out of the bag here. What if the object wasn't just moving this way, wasn't just moving that way, but it was going up and down and left and right and towards you and away from you? What would you venture this would look like for the total distance traveled in 3 space, not just 2D?
Plus the dz dt.
Yes, plus the rate of change of towards you and away from you squared, right? You had a third component squared in there. Actually how it works out. You'll get there someday if you end up taking calculus. Okay, so it is definitely time to do stuff instead of just talking about symbols. Y'all ready?
No.
Ready or not? Here we go.
Mr. Anderson, you ready? Us, a collective
Wait, is this going to be on
Wow.
final?
This YouTube comment section already in that class. YouTube
Come
comment
on,
section's
Sam.
the worst now. You should just
And we have all of next week to review too, so you'll be in good shape.
That's true.
Yep.
Now I have something to do next week.
It's funny how like that week that gets X'd out, we just kind of forget that it's there and we think, oh, that doesn't count.
Yeah.
It's there. It's there. I actually get to see you guys 3 times. 2 shorts and a long. Yeah.
Otherwise, I would really miss.
So,
I would miss you too.
final wise, is it just the final on the finals day?
So you
Yeah.
just want
Okay.
We got our quiz this week and that's it. And the final, whenever it's on the Wednesday, I think.
And then everything is just preparation up to that?
Yeah, totally. I've got some good stuff for next week preparation-wise. I think I'm kind of excited to see what you guys do with it. Should be
Wait,
good.
what are we doing next semester?
Polar
Uh,
Power Series.
ooh, that's gonna be exciting.
That's the big one. It's very cool. It's very cool. Hey, will you guys try 1, A, and B? 1A and B.
Yep, Megan is that is correct.
If you are hung up on the I hat, J hat, because that's usually done in physics, you're certainly welcome to use that, and it's good. It's very good notation. You'll see me use the pointy parentheses on stuff like this, but feel free to use good symbols, whatever they happen to be.
Oh, Logan.
I don't think I should. I don't think I think I just killed it.
Let's find out.
Wait a minute. Wait, no, I did it
No,
wrong.
I'm not done. I'm not.
Oh, you're not done?
You're not done. Wait, no, you're so silly. You're so silly. That's not it. We have 2 more minutes.
No, of course. I just thought you were so excited. I thought let's do this.
Julia just totally messed me up. and
Okay.
It was her fault. Yeah, right.
Blame it all on Julia. Yeah.
Okay, Meg.
Okay.
Brain function. Oh my gosh, Megan. Here. This is not probably that
Roasting Meg so much.
This is not probably that aggressive. I was kidding.
And Santi's over here saying, "Man, I got a visa today."
Yeah, I really did.
Coordinates, right?
Yeah, it should be pointy parentheses, something, comma, something. You don't have to go to the vector form. I just want to see component form. That makes sense?
Okay.
You don't have to do like the Pythagorean theorem and find the angle.
Wait.
I don't know if that's. I don't know if is that what you're thinking of?
But can you just do dy dx? Just one value, but it's a component.
Show me the components. Yeah, we'll always do components.
That's what it was.
Okay.
Yeah, the only time we won't do components is like when we're doing speed, and you got to just get a singular value for speed.
That's what we did. Yeah. Don't sleep. Don't sleep on us.
You don't even do dy
No, this is great. This is so good. I don't have the answer memorized. That's the right form for sure. Like that's what the answer should look like.
We're so smart.
Definitely the answer should look like it. We'll figure out if the numbers are
Probably
right.
the smartest in class.
Hey, you know what? That could be the case. Okay. Hey, let's. Hey guys, listen up. Just like listening to you and like hearing some of the things that you did try to do. Let's talk about this. Let's talk about why we are not trying to find this. What would the question have to ask you in order for you to do that?
The velocity.
No.
Huh? The velocity at t equals.
No, that's not the velocity at t equals 1. No. So you keep wanting, you Aiden, when you start off by saying the slope of the, I'm like, yes, that's right. But it's the slope of the what that we're talking about. Like, what is the thing we're finding the slope of if we did that? That's a little too generic, right?
Oh.
How about the positions graph, the position functions graph? I can go with that, yeah. This would be the slope of the position functions graph. I can go with that. I'm going to erase all this here in a second. So if this object was moving like this, something like that, we could find the slope of that actual path right there. That's what dy dx would find.
So that's only just for tangent.
That's if you're trying to find the slope of the tangent line to that graph. And that's not what it asked. It very well could ask that. You are going to find questions that do ask that, but that's not what this is asking. This is saying, what's the velocity vector? Like, what are the velocity components? And so we are not going to be finding dy dx. We're going to be finding just literally what are the components of velocity. So
Slope of the function of the graph.
that's too generic. I would say it's this, like dy dx would be the slope of the position functions graph. Like if we were to graph, like you've got your two Like you guys could take your calculators and you could graph that, couldn't you? Put it in parametric mode and graph it. It's going to come out to be this crazy curvy graph, right?
Yes.
You could find the slope of that particular graph at any point. That's not what this is asking, though.
No.
So, wouldn't that just be the direction too, the direction that the object is traveling?
If you did the inverse tangent of it, that would give you the angle from horizontal.
Okay.
Inverse tangent of dy dx would give you theta. Okay, so here's what you should do. You should find x prime of 1, comma, y prime of 1. So x prime of t is 3t squared plus 8t. So Meg, that first number, looking pretty good, right? 11.
Yes.
Y prime
I calculated.
of t is equal to 4t cubed minus 3t squared. So y prime of 1 would actually be 4 minus 3, which is 1. Meg, that number you had, I think was right. So your velocity vector is 11, comma 1.
Still got a 95 on her physics test.
Hey, what does that mean though? Which way is this? Hey, which way is this object moving?
Right up.
Which way more? Is it moving more right or more up?
Right.
A lot more right and just a little bit up, right? Okay, good deal. All right, and then the acceleration vector.
That's just one more derivative.
Yep, that'd be x double prime of 1, comma y double prime of 1.
No, it gets.
Oh, we're doing 2. I didn't even read that part. How about 2? There we go.
You got a written question?
So x double prime of t would be 6t plus 8. So this would be 12 plus 8. So I got 20, comma. Y double prime of t would be 12t squared minus 6t. You plug in a 2, you get 48 minus 12. Y'all get this? 20, comma 36.
It's okay. Don't worry.
Is it outside? Please.
Hey, this is where we're getting some foundational stuff in place. Are you okay with what we did there versus the whole dy dx,
Yes, that makes
d
sense.
squared y over dx squared thing? So be really careful about saying the second derivative, blah, 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 because it's just too generic. Say dx dt, dy dt, or dy dx. Be better for you. Okay. Number 2 says a particle is moving around in the xy plane so that the position is described by x of t and y of t. Hey guys, when you see this phrase right here, what would be a single word you could substitute in for that phrase? Single word.
The speed.
Speed.
Julia got it right. Yeah.
She just said it so quiet.
Yeah, I was just unconfident in my answer, so I was
Are you
like,
kidding me?
You're such
Are you
Hey,
kidding
Meg
me?
gave you
That
credit,
is
so there you
not-
go.
Okay,
Thanks,
you
Mike.
Good.
Shut up, Princess Sarah.
Okay, so if it said find speed when t equals 1, we would do the exact same thing as what you should be doing here, okay? So please take a minute. You can flip back and look at the little formula. You've got a formula that addresses this directly.
Is that how you do that? What's that do? What's that do?
Oh, yeah. Double, oh man, what's the word for that? Shoot, there's a word for that. But yes, that does give you magnitude. What's that word? The double vertical lines around the V.
Just
That's got a word. It's been too long since I took college physics. Or Calc 3 even too.
I know what you said.
There is a word for that.
I give you $20 for that.
well, I think I got the right answer anyway. So I hope if I did my mental math.
Can I just velocity vector and get
Yeah, that's all you're doing. That's all you're doing. I agree.
Okay, I wasn't sure. Sorry.
Okay, so here's where you'd go with this one.
I just need to memorize these like the form.
I think you're gonna be fine. I'm not worried about you.
Memorizing is good, Julia, but let's go for like why and how and what's actually happening as best we can. So if you ever look at it and you're like, well, that's a neat.
It's like once I understand the form, I'm like, oh yeah.
Yeah, well, let's.
Like just not coming right out of my brain right now.
Okay, that's all right.
Yeah.
The quiz is not right now.
No.
Let's keep at it.
Only Friday.
You'll see this all week.
Okay.
Yep, you'll see this all week. Okay, so if I'm trying to find speed, I need to know velocity components. So here are my two velocity components.
That's all the Zayu values.
And then I need to know what the velocity components are when t equals 1. So I'm going to write x prime of 1. That would give me 5. And y prime of 1. That would give me negative 3.
Yes, sir.
And the way that you find speed, or the magnitude of the velocity vector, is square root of dx dt, quantity squared, plus dy dt, quantity squared. So at this point, it's a pretty simple plug-in. It would be 5 squared plus negative 3 squared. So that would be square root of 34.
Square root of what?
25 plus 9. Oh,
You just didn't write the square on top.
you know, sometimes, darn it. Yeah, sometimes, so this is supposed to have palm reject, and sometimes it rejects my pen. Like when I put my hand on the screen, it's supposed to reject my palm and only see the pencil, but I think I said it and it just didn't get on the screen. What do y'all think? Square root of 34?
Yes.
Okay, so I think this next one will be our very last one for today. Number 3 says particle moves in the xy plane so that you have an x component of position and a y component of position. The particle intersects the x-axis twice. Write an expression for total distance traveled between those two x-intercepts. Says no calculator.
No. I don't like it.
This is so doable because you don't have to actually evaluate this. It's very doable. Okay, take a few minutes, try it
Oh,
out.
it just says write an expression.
Yep, you don't have to evaluate or anything, just write the expression. By the way, it's very likely that we will completely wrap this up on Wednesday morning, and Thursday will be a review day. This is not a lot of material here. We'll just get some good practice and get as broad of an experience as we can. Have a chance to review on Thursday.
Do not evaluate. Do not. I love that.
Wait, what if we evaluate it? Would we get like voted down?
So in those situations, usually like if somebody just continues on, it kind of varies. What I personally tend to do is just say, you're good. Sometimes the AP folks will actually keep reading, and if you make mistakes, that you potentially lose a point.
Oh shoot, that's brutal.
Because if you write stuff, it needs to be correct.
Yeah.
So you just do what they ask you to do. No more, no less.
Right next to the extra part, I never saw this.
Just put a big X through it.
The only time where the bare minimum is perfect.
Right.
The test.
Yeah. Or I mean, if you go beyond the bare minimum and you do it right, that's okay too.
But it doesn't benefit you.
It's a no-win situation. If you do it all correct, you didn't get any extra.
Wow. I wrote it and I didn't
What
evaluate
is
it.
satisfaction if completing though?
That's great. Just have correct one.
I'm right. Didn't evaluate it.
When he doesn't evaluate.
Correct one.
You took my bag.
There's
When
something
he
called
writes
type
it,
fun.
oh my goodness, and then he doesn't evaluate it. Oh,
Type 1 fun would be like eating bowl by screen and watching a movie. Type 2 fun would be like finding a 14er.
Oh yeah.
Right? It's fun.
I'm a
but
type
it
1
hurts.
fun.
There's only one fun.
I'm type 1.
You're type
I'm
1.
gonna type 3.
Are we talking about like Enneagram or like?
No, like type 1 fun is like watching a movie or going to an amusement park or something. Type 2 fun is climbing a 14er. Right? There's pain involved, but it's still fun. Right? You accomplish something. It's good. Oh. There are people that are totally into type 2 fun. Other people like both. Other people combine the two, like bring good food while you backpack.
Oh yeah, that's
Oh,
totally.
That's not bad.
Like
That's the move.
Like
It's a nice
bring a
cheese.
Wi-Fi hotspot so we can chill. We can have some Netflix after we climb the mountain.
Right, yeah. Hey, Rocky Mountain National Park, where's the Wi-Fi on top of Long's Peak? And where's the
excellent
pizza stand,
reception
really?
up
I'm hungry.
Yeah.
Someone should open a shop on just like the top of like all the
Oh, that would
mountains.
just be so lit.
Well, I bet you Pikes Peak has Wi-Fi because they got the little restaurant and all that junk up there. I'm sure they have
In the
Wi-Fi.
race.
Been there, so.
Yeah. Okay, I don't know what's happening, but we're going to wrap this up. Hey, if this particle intersects the x-axis, how would we find when that happens?
When y equals 0.
When y is 0, right? So I would set the y component to 0. So I would say 0 equals 1 minus 2 sine of t. That's the key, right? If the particle is on the x-axis, we don't know what the x coordinate is, but we know that the y is 0. So I would subtract this over and divide. I'd get 1/2 is equal to sine of t. This is very doable without a calculator, if you know your unit circle type stuff. So what's the inverse sine of 1/2?
Pi over 6.
Pi over 6, I think.
5
Pi over 6. And there's another one, because we're going 0 to 2 pi.
5 pi over 6.
5 pi over 6. So those would be the two times when the particle is hitting the x-axis. So to set up the total distance traveled, I would go integral from pi over 6 to 5 pi over 6. Essentially the integral of speed. So dx dt would be 4 sine of t, and it's quantity squared, plus the derivative of y with respect to time would be cosine. So this would be negative 2 cosine of t quantity squared dt, and that would be your total distance traveled between those two times. Okay, so come ready to go tomorrow. We'll just have a few more of these examples. Like I said, we'll probably wrap it up and finish it tomorrow, and a review day on Thursday, or not tomorrow, Wednesday. You know what I'm saying. Have a good rest of your day.